Hey everybody, we are going to start our Algebra 2 class here with a little bit of review. So we're going to talk about real numbers and number operations today. Okay, so a real number is a number that can be placed on a number line. Okay, there are other numbers. We're going to talk about imaginary numbers later. Imaginary numbers, they don't fit on a number line, so that's why they're not real. Okay, the point labeled 0 on a number line is called the origin. Okay, points to the right of 0 are called positive numbers, points to the left of 0 are called negative numbers, and 0 is neither positive nor negative. So right here, okay, we've got our we've got our positive numbers over here, and we've got our negative numbers are over here. They're on the left, and of course we've got our origin right there. Okay, so any number that I can put on this number line is a real number. Okay, the scale marks, that's these. Of course, on a number line, they're equally spaced, and they often represent integers. So in this case, they are integers. Okay, they don't have to be integers. They can be fractions. They could be even irrational numbers if you really wanted them to be, but usually we use integers. Okay, a point on a number line that represents a number is called the graph of the number. So if I were to graph the point 3, okay, it would go right there. There's the graph of 3. All right. So types of numbers. You got your natural numbers. 1, 2, 3, 4, 5, 6, 7. That's just your counting numbers, right? You got your whole numbers, which are the natural numbers plus 0. You've got the integers, which are your whole numbers plus the negative natural numbers. You've got rational numbers. Rational numbers, remember, are any number that can be written as a fraction. Okay? So this includes all your natural numbers because I could write 2 as 2 over 1. It includes 0 because it's 0 over whatever you want. 4, say. That would be a fraction. It includes all mixed numbers like 2 and negative 2 and 4/9. Improper fractions like 22/7, so on. Okay. Any regular fractions like 1/6. Then we've got irrational numbers. Irrational numbers are numbers that can't be written like fractions. For example, pi. Now, 22/7, you might recognize, is very close to pi and is often used in place of pi. But it's still, pi can't be written as a fraction exactly. Neither can the square root of 2. Neither can the number e. Okay. Basically, any square root that doesn't come out to be a nice number is irrational. Okay? Now, if I take all these numbers together and I combine them, that's the real numbers. Okay, we're going to sketch the graph of the real numbers, negative 2/3, square root of 2, and 5/2. Okay, so negative 2/3, we'll do that in green. So negative 2/3 would be not quite negative 1, so it's going to be like right about here. We're going to estimate, and we're going to label it negative 2/3. Okay, square root of 2. Now, if I square root 2 with my calculator, I'm going to get about 1.41. Okay, so that would be not quite 1.5. It'd be like right about there. So we'll call this the square root of 2. And 5/2, that would be 2.5. It's going to go right smack in the middle right there. Okay, we'll call that 5/2. So I've graphed my 3 real numbers there. Okay, a real number line can be used to order real numbers. So if you get a whole list of numbers, you can put them on a number line, and you can always tell the largest, because the largest will always be on the right. Smaller will be on the left. Now, if we go back and look right here, a lot of times People think negative 10 is bigger than negative 1 because 10 is bigger than 1, but it's not. It's actually less than negative 1. Remember, the further you go to the left, these are smaller and smaller numbers. Okay, the further you go to the right, they're bigger and bigger numbers. So negative 1 would be bigger than negative 2. It's a very common mistake that people make. You can use inequality symbols like less than or equal to, greater than or equal to show the order of numbers. So here we have 2 is less than 5. We can write it like this. 2 is less than 5. Or we can say 2 is to the left of 5. Negative 1 is greater than negative 4. So we can write negative 1 is greater than negative 4. Or negative 1 is to the right of negative 4. Okay, the lowest elevation in the United States is Death Valley, California, elevation negative 282 feet. Milwaukee, Oregon has an elevation of 46 feet. Mount McKinley, now known as Denali in Alaska, has the highest elevation in the United States at 19,685 feet. Mount Hood, Oregon, the highest place in Oregon, is 11,234 feet. New Orleans, Louisiana, is at negative 8 feet. Denver, Colorado, is at 5,280 feet. Hence, it is called the Mile High City because it's exactly a mile above sea level. Detroit, Michigan, has an elevation of 597 feet. So place them in order in a number line. Okay, so first we would have to figure out what numbers do we want to have on here. We've got to go from negative 282 at the lowest up to 19,685, which is the highest. Okay, so I don't know. I would probably start here at, say, 19,700 at the top. And I would probably, I don't know, what do we have here? 1, 2, 3, 4, 5, 6, I don't know what spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 spaces. Probably want to go by thousands of feet. So this would be 18,700, 17,700, 15,700, 13, 12, 11,700, 10, 9, 8,700, 7, 6, 5,700, 4, 3, 2,700, 1,700, 700. This would be 1,000 less than that would be negative 300. Oh, called that pretty good. Okay. So we can fill these in between if we need them. So I've got my numbers spaced out here evenly. Although I'm filling these in, that doesn't look too nice, but there we go. Now we're all dialed in. Okay, so now we can place our numbers on here. So negative 282 feet, that's going to be pretty close to this. Okay, we're going to label that. That's Death Valley. Okay, so we've got that one done. Milwaukee, Oregon is at 46 feet. Wow. Okay, so we don't have a 0 on here. Milwaukee's going to be kind of right here. Let's see. Mount McKinley, 19,685. That's going to be almost right there. We'll just label this Denali. Okay, Mount Hood, 11,234 feet. That's going to be not quite here. It's going to be right about there. Mount Hood. New Orleans. Okay, this is going to be really tight in here. So that's going to be -8 feet. That's going to be in between here. So we'll use a different color. This is going to get real bunchy because my graph's so tight. Denver, 5,280. That's going to be right about here. And what do we got? Detroit, 597. So that's going to be right about here. Whoops. Yeah, Detroit. We're going to label that Michigan because there's a Detroit, Oregon. We don't want to get that confused. Okay, so there we've got it. Now we can easily tell what order these are in. Death Valley is the lowest, followed by New Orleans, followed by Milwaukee, followed by Detroit, followed by Denver, followed by Mount Hood, and then Denali is the biggest because it's the furthest to the right. Okay, let's go back and review some of our properties of real numbers, like the commutative property. So we got two commutative properties, one for addition, one for multiplication. So a plus b is equal to b plus a. 3 plus 2 equals 2 plus 3. Both of them are 5. 3 times 2 is equal to 2 times 3. Both of those are 6. So that works. The associative property. A plus B plus C is equal to A plus B plus C. Okay, so it doesn't matter what order you add in, you get the same number. Same thing with multiplication. A times B times C is equal to A times B times C. Okay, so I can multiply in whatever order I want as well. The identity property. So the additive identity is 0. Now, an identity is a number that when you do some kind of problem with it, you get the same number you started with. So a plus 0 is still a. The multiplicative identity is 1 because a times 1 is equal to a. Inverse property. Okay, so for addition and subtraction, that's the number that gives you 0. So a plus negative a equals 0. 3 plus negative 3 is 0. Negative 6 plus 6 is 0. Okay, now the identity for multiplication, you don't get 0 because you can't multiply two numbers and get 0 unless one of them is 0. So that one is what comes out to be 1. So a times 1 over a is 1. 2 times 1/2 is 1. 3/4 times 4/3 is 1. So this is the reciprocal of this number right here. Distributive property. A times B plus C is equal to A times B plus A times C. Okay, so all those you should be aware of. The reciprocal of A is 1 over A, as long as A is not 0. Okay, so the number 0 does not have a reciprocal. You can't take 1 over 0. You can't take any number and divide it by 0. Okay, so 0 can never be in the denominator. 0 doesn't have a reciprocal. All right, so we got an example here. Find the sum of negative 12 and 14. Okay, remember sum means to add. So negative 12 plus 14 should be 2. Okay, find the difference. Difference means to subtract. So you're always going to take the second one away from the first one. So this would be 5 minus negative 13, which is 5 plus 13. Remember, when you have two negatives together, that becomes plus a positive. And so that's 18. Find the product of -3 and -11. So remember, product means to multiply. So -3 times -11. 3 times 11 is 33, and a negative times a negative is a positive. So my answer is 33. And then quotient, of course, means to divide. And you always divide by the second number. So the quotient of -42 and -21 means -42 goes in the numerator, -21 goes in the denominator. Negative divided by negative is a positive, and 42 divided by 21 is 2. And you're done. Piece of cake. Okay, so very, very simple lesson today, just to kind of review and get things back on your mind after a little break. So have a great day. I'll see you guys in class.